Introduction to Unit 3.1, Introduction to Vectors. This is really important. Since this is a flipped class, the notes will be online at sophia.org. It is extremely important that you watch them and take notes. I will show today's notes and we can quickly go through them, but I won't be doing this in the future. If you have not logged into sophia.org yet, the class code is 896011. The unit that we're going to be looking at is two-dimensional motion and vectors. Today and tomorrow we'll be looking at the intro to vectors. Wednesday and the following Monday we'll be looking at vector operations. The 10th and 11th will be projectile motion, and the 12th and 13th will be relative motion. The learning targets for today's unit include: I can describe and distinguish a scalar and a vector quantity. I can add and subtract vectors using graphical methods. I can describe how to add and subtract vectors using graphical method. Scalars and vectors are not the same thing. A scalar quantity only has magnitudes. A vector quantity has both magnitude and direction. Examples of scalar quantities include length, area, volume, speed, mass, density, pressure, temperature, energy, entropy, work, and power. Vector quantities include displacement, direction, velocity, acceleration, momentum, force, lift, drag, thrust, and weight. A scalar quantity is only a quantity in physics that has magnitude only. So you're looking for number value with units. Vectors, on the other hand, have a quantity that has both magnitude and direction. An arrow above the symbol illustrates a vector quantity. It indicates magnitude and direction. Vectors are represented by symbols. If the type is bold, as it is in the first instance here, or it has an arrow above it, it is considered a vector. Scalars are often represented by using italics. So the V in 3.5 meters per second is a vector below, and the bold V, or the V with an arrow over it, is a vector quantity. Vectors can be moved parallel to themselves in a diagram. Vectors can be added in any order. To subtract a vector, add its opposite. For example, if you add two vectors that are in the same direction, you simply add them together. A man walks 46.5 miles or meters east, then another 20 meters east. The total is 66.5 meters east. On the other hand, if this same man walks 46 meters east, then another 20 meters west, you calculate his displacement relative to where he started from. And so you would subtract 20 meters west from the 46.5 meters east, and you would have a displacement of 26.5 meters east. In the example displacement asked for, since it's a vector quantity, you also need to report the direction. Note, when you're drawing a right triangle that conveys some type of motion, you must draw your components head to toe. So it will be the head, the toe, or the head of this to the toe of the second vector. This is the toe, this is the head, this is to the next head, toe, going to the head, and you draw it from this point to this point. So this particular vector is going north of east. This is an activity you can do online to practice vector addition. This is the website that you would go to in order to see that. We're going to be doing something called modeling, and we're going to be doing a modification of the types of modeling we would be doing. Each group will have a whiteboard, a dry eraser marker, and a rag to clean the whiteboard at the end of the period. You will work on an assigned problem from the worksheet on your whiteboard. What needs to be on the worksheet would be your names, the problem written out, a drawing, and finally your answer. You also need the scale. We'll be doing a practice problem in class so that you have some idea of what I'm looking for. Homework is very simple. You're going to watch next period's video at sophia.org and take notes.